Hey y'all, welcome to College Prep Math. This is a course designed to help students prepare for the TSIA2 exam. And so as we go through the course, we're going to cover all the topics that you're going to need to know to be successful on that test. In this unit, we're going to focus on solving linear equations, systems of linear equations, and linear inequalities. On top of that, we'll get into how to set up word problems so that you can solve it using the same techniques. Now for today, for our first lesson, we're just going to focus on the steps that are going to be required to solve a linear equation. So just to kind of break it down, a linear equation is going to be any equation that has an x or some variable, but not x squared or square root or anything like that. An equation is just a statement that two expressions are equal, and when you try to solve an equation, what you're trying to do is trying to isolate or get the variable by itself. There are some properties that we are going to go over kind of lightly to help you know what to do on each of these linear equations, but you won't necessarily need to know these properties by name. It's just as I'm describing them, I'm going to use the name of the property so that you start to recognize like when to use it and when not to use it. Now, basically our overall goal here is to get x or whatever the variable happens to be by itself. So like in this first equation, x plus 4 equals negative 12. Ultimately, what we want is we want to know what value can I replace x with to make that equation true. And you might know what that answer is just by looking at the equation, especially if they're not too complicated like any of these that you see on your screen. But I still want to encourage you to show the steps that I'll show you so that when we do get to the more complicated ones, you have some kind of framework for how to find the solution without trying to do everything in your head. So yeah, we definitely want to get x equals something. But the way to do that is to undo any of the operations that are being done to that variable. So like on this first problem, we have x plus 4, and we want to get rid of that plus 4. We just want it to say x equals something. And so to undo any of the operations that are being done to your variable, you need to do the inverse operation. So inverse operations, the inverse of addition is subtraction. So whether you see plus or minus. Also, multiplication, I'll just write out a little dot for multiplication, and division. You typically won't see these two symbols written, but they're probably the easiest way to communicate this through text. So whenever you see something like x plus 4, to get rid of that 4, you're going to subtract 4. So I'm going to write minus 4 here. However, you can't just arbitrarily take away terms from a side. This is where the properties of equality come in. There's a bunch of them, but overall, what they all kind of mean the same thing, which is to say that whatever you do to one side of the equation, you have to do to the other. Otherwise, you're changing what the equation is. Like if I just subtract 4 from the left-hand side here, and I write x equals negative 12, negative 12 is not the solution that I want because negative 12 plus 4 isn't negative 12. So if I were to subtract 4 from one of these sides, I also have to do it from the other side of the equation. Now 4 minus 4 is 0, and that leaves us with x, which is what we want. Negative 12 minus 4 is negative 16. And let me just make a quick remark about that subtraction there. You should be using a calculator on any arithmetic that you do. That means addition, subtraction, multiplication, division, and especially when we start throwing in negatives and fractions, don't count on your mental math to take you through it. You're going to get at least a 4-function calculator on the TSI, so put it to work. Okay, the TSI is not timed, so there's no rush. Type it in and make sure you get the right answer. Okay, the second one is x minus 6 equals negative 5. Now we want to get, again, x by itself. So we're going to try to get rid of that minus 6. And the way to get rid of that minus 6 is to add 6, because 6 minus 6 is 0. And just like with the previous problem where we used a property of equality, we're actually going to use the addition property of equality here. It basically means the same thing, which is that we have to do the same thing to both sides of the equation. So 6 minus 6 is 0, and so we're just left with x on the left-hand side. Negative 5 plus 6. I've got a little scientific calculator over to the side here. I know you can't see it, but I'm typing in all this arithmetic, so I make sure to get it right. Negative 5 plus 6 is 1. You just don't really want to get a problem wrong because the arithmetic was wrong, especially when you get to use a calculator. That is going to feel bad when you feel like you did all the algebra correctly. Okay, so let's take a look at the next one. We have 10n equals 40. Now, one thing to know here is that if you don't see an operator there, it is assumed to be multiplication. So 10 times n. And that'll help when we're trying to figure out what the inverse of that is. Okay, the inverse of multiplication is division, so we want to divide both sides by 10. Now, I'm not going to write this division symbol, okay? Instead, I'm just going to draw a fraction, and it basically means the same thing. If we want to divide both sides by 10. Ten divided by 10 is 1, and so we'd have 1n, which is what we want, equals 40 divided by 10 is 4. Now the next one has division. K divided by 11 equals 6. And so we want to get rid of that divide by 11. Okay, by the way, this little division symbol, this is just kind of a side note here. You may or may not have ever noticed this. But, getting used to these fractions being division is really just a matter of really recognizing what this symbol is, right? Like, this division symbol is just literally a fraction. There's your numerator, here's your denominator, there's your fraction bar. So, and that's the order in which you would read it and do the operation anyway. So that's kind of why that division symbol looks the way it does. All right, anyway, we've got k divided by 11, and we want to undo that divide by 11. So we're going to multiply both sides by 11. 11 divided by 11 is 1, and that's how we get those to cancel out or reduce each other, however you want to put that. And so we get k equals 66. Okay, so those are our properties of equality. You can add, subtract, multiply, divide both sides by basically anything you want as long as you do it to both sides. Now, sometimes you'll have multiple terms on either side of the equation that have an x, or maybe they'll just be constants. And anytime you've got more than one term that sort of falls into the same category, whether it has an x or not, those are considered like terms. And you can combine like terms by just simply adding or subtracting them if they're positive or negative. So let's start. I think it'd just be wise to just kind of jump into the examples here. I think you'll see it pretty quickly. On this left-hand problem, we've got 8x plus 5 minus 3x equals 8x minus 4. So on the left-hand side, notice how we've got an 8x minus 3x. Okay, those are considered like terms because they both have an x, and we could put those together. 8x minus 3x is 5x. So we've got 5x plus 5 equals 8x minus 4. Now also notice at this point, there's no like terms on either side of the equation, but we do have an x term on both the left and the right-hand side. Now, if they're both on the same side like we just saw, you just combine them like you normally would. 8x minus 3x is 5x. But if they're on opposite sides, then you're going to need to sort of collect them over on the left-hand side. And so to get rid of that 8x from the right-hand side, we need to subtract it away. And so we're going to fall back on those properties of equality. We're going to subtract 8x from both sides. On the left-hand side, we have 5x minus 8x, and 5 minus 8 is negative 3. Again, throwing that in your calculator. So we get negative 3x plus 5. 8x minus 8x is 0. Those go away. That's kind of the whole point of subtracting the 8x. And we get negative 4. Now, on all the examples that we had in on the previous slide, these were all considered one-step equations because you're only really doing one thing to each equation. There's only one operation that's affecting the variable. Now, if you've got two, now we have this question of like, well, what should you do first, right? Should I get rid of the addition, subtraction, or should I get rid of the multiplication, division first? And what you want to think about is like when you're doing normal arithmetic, like let's say you're doing 3 times 2 plus 5. Right? The order of operations, and sometimes you'll know that as PEMDAS, is like an acronym to help you remember, but the order of operations requires that you do multiplication before addition. So this would be 6 plus 5 is 11. right? But when you're trying to solve an equation, you're trying to undo the operations being done. And so you'll follow PEMDAS, or that order of operations, backwards, and you'll want to undo the addition and subtraction before the multiplication division. So to undo that plus 5, we're going to subtract 5 from both sides. Just make sure you do that step first before getting rid of that negative 3 on the x. So when I subtract 5 from both sides, I have negative 3x equals negative 9. And now I can get rid of that negative 3. It says negative 3 times x. So the inverse operation there is going to be division. And I'm going to divide both sides by negative 3. That'll give me x equals 3. And that is my final answer. For the next problem, we've got x minus 10 plus 7x equals 15 plus 3x. We see that the only like terms that we have here are going to be on the left-hand side. We've got x plus 7x. And this is a good opportunity for me to remind you that anytime you've got a variable with no number in front of it, there is an implied 1 there. You don't necessarily have to write it there. If it helps, then yeah, go ahead and write it. But like I said, you don't have to. But yeah, so we've got 1x plus 7x, that is 8x. So we have 8x minus 10 equals 15 plus 3x. Now I'm going to use the properties of equality to isolate the x. First, you want to get rid of the x on the right-hand side. So we're going to subtract 3x from both sides to get rid of that. 8x minus 3x is 5x. So now we have 5x minus 10 equals 15, just 15. Now we've got it set up kind of like at this point where we've got a two-step equation. And so we're going to follow the same order of steps here. We're going to get rid of the either addition, subtraction first, and then deal with the multiplication division. So here we're going to get rid of the subtraction first. We're going to add 10 to both sides. Now adding 10 to both sides is going to give me 5x equals 25. So we have 5 times x equals 25. Multiplications inverses division, so we want to divide both sides by 5. And we'll get our answer, x equals 5. So we've got these properties of equality. We've got the ability to combine like terms. There's really just one more property that you need to be familiar with, and that is the distributive property. The distributive property explains how to combine addition and multiplication. And basically the way it works is if you're multiplying some number, we'll just call it a, by some of two numbers is what you get when you add them up. Then one thing that you can do to combine them is you can multiply the number on the outside by each term on the inside. So this would be like a times b plus a times c. I tried to color coordinate there. I don't know if it really came out as good as I wanted it to, but that's good. Now, when you're using the distributive property, usually this is going to be the first thing that you do if there is any instance of the distributive property in your equation. But what I want to show is there's actually two ways that you could solve an equation like this. So first, I'll kind of go over sort of the traditional approach, which is just to apply the distributive property directly. So if I distribute this negative 2 to both 4x and negative 3, I'm going to multiply negative 2 by each of those two terms. So negative 2 times 4x is negative 8x. Negative 2 times negative 3 is positive 6. And now we've got a two-step equation. To solve that, we're going to subtract 6 from both sides. That'll allow us to get rid of the 6 on the left-hand side. 30 minus 6 is 24. So we get negative 8x equals 24. And then finally, we'll divide both sides by negative 8. And get our final answer here, x equals negative 3. So this is one way that you could approach it. There is another way you can deal with this when it's set up where it looks like the distributive property. And that is if that number on the outside is just a number, then you can actually divide both sides of the equation by that number. So here's an alternate path to victory here. If I look over on the right-hand side here, this equation, I'm going to divide both sides by -2 first. Okay? If I do that, I get 4x minus 3 equals -15, which looks still looking a little different than the problem we just did, but you'll see in a second here. If I add 3 to both sides, -15 plus 3 is -12. So I have 4x equals -12. And then finally, dividing both sides by 4 is going to give me the same answer that I got on the last one, which is -3. So I get x equals -3. Either way, now I will usually solve it using this method over here on the left-hand side. So over on the right-hand side, mostly I would use that. If that makes more sense to you, by all means use it. But I just find that that particular method is really only good for if you're trying to keep the numbers as small as possible, but you're going to have access to a calculator, so I really wouldn't even worry about how big the numbers are getting. But you can imagine if you didn't have a calculator and that number on the outside was something like 156, like you don't want to deal with the multiplication, and then it just makes all your numbers really big. So it might be better to do that division up front. I just want to show you both methods just so you have a choice. But if I'm working it out, I'm definitely going with that left-hand method. So let's look at some examples that have some distributive property built in. Okay, since this is the last property we're going to be using, let me go ahead and just outline like the order of these steps that you typically are going to want to do. There's always corner cases where you might switch it up. But in general, the first thing you're going to want to do is look for any distributive property. Let's see, distributive property. So if you ever have, if you see parentheses with a number on the outside, multiply that out first. Then after using the distributive property, you're going to want to look for opportunities to combine like terms. Finally, once all the like terms are combined on both the left and the right-hand side of the equation, then you are going to use your properties of equality. Okay, and these are going to be kind of your 1, 2, 3 steps to victory here. Now that last step, the properties of equality step, is going to do quite a bit of heavy lifting there. The distributive properties should only be 1 step. Combining like terms, unless you're just kind of trying to separate it out, you can usually knock that out in a step also. But the properties of equality, you might need to use more than one. So that might be 1, 2, maybe even 3 steps. So let's take a look at the left-hand problem here. I do notice I have some parentheses here. Right, this x plus 4 is in parentheses, so I'm definitely going to want to use the distributive property and distribute that -3 to both x and to 4. 3 times x, or -3 times x is -3x. -3 times 4 is -12, so don't really want a plus there. I want a -12 plus 1 equals, and I'm not really going to mess with the rest yet. Okay, so next I'm going to combine my like terms. I executed the distributive property, and now it's time to combine like terms. On the left-hand side, I see I've got -12 plus 1. And on the right-hand side, I've got 3x plus x. So you definitely want to be looking for both the terms that have an x and the terms that don't. So on the left-hand side, -12 plus 1. Again, using that calculator, don't be afraid to use it every time you got to do a little arithmetic. Is we have -3x minus 11. And on the right-hand side, I've got 3x plus x. Remember that x is really a 1x. So I've got 4x minus 4. Now I'm going to use my properties of equality. So this is going to actually take 3 steps, but they're all properties of equality where I'm doing the same thing to both sides of the equation. The first thing is I want to get that x over to the left-hand side. So I'm going to subtract 4x from both sides. -3x minus 4x is -7x. So I have -7x minus 11 equals -4. Then I'm going to take care of the addition or subtraction before multiplication division. In this case, I want to add 11 to both sides. That gives me -7x equals 7. And finally, I can get my answer by dividing both sides by -7. And 7 divided by -7 is -1. All right, on this next one, I'm going to basically go through the same set of steps. It's just going to be a little bit more practice here. I'm going to distribute that 2/3 and also do a little distributive property over here by distributing that -2. All right, so 2/3 times 3 is 2. So don't be afraid to do that in the calculator. Also, just 2 divided by 3 times 3. 2x plus 2/3 of 9 is 6 equals, and now I'm going to distribute that -2, -4x minus 12. Now I'm going to I'm looking for like terms, and there are actually no like terms for me to combine, so I'm going on either side. So I'm going to skip that step and go to my properties of equality. First, I'm going to add 4x to both sides. 2x plus 4x is 6x, so I have 6x plus 6 equals -12. Then I'm going to subtract 6 from both sides. And that gives me 6x equals -18. Now I need to get rid of that 6, so I'm going to divide both sides by 6. And I get my final answer, x equals -3. Now, the good news is this is about as complicated as linear equations are going to get. I can't really make them more complicated unless I throw in some bigger numbers or fractions or something like that. But really, with the use of a calculator, it can't really get that much more complicated than this. Now, there are some kind of weird corner cases that might occur. We call these special cases. And this is where you have an equation that either has no solution or every number is a solution. So if an equation has no solution, we call that a contradiction. And if an equation has infinitely many solutions, or more specifically, if every number is a solution, we call that an identity. So let's look at these two equations and just kind of explain a little bit more what I mean. If I have x equals x plus 1, you might try to figure out what that answer would be, but any number you plug in, like let's plug in 3. 3 equals 3 plus 1. That can't be right, and 3 doesn't equal 4. And no matter what number you try to plug in there, because the right-hand side is just adding 1 to it, those numbers are never going to be the same. So this would be an example of a contradiction, and contradictions have no solution. But let's go through the algebra to kind of show like what's going to, maybe you don't notice it right away. Like this one's kind of obvious that it doesn't have a solution, but it might not always be so obvious. So if I were to go through the steps that we've outlined already and use those properties of equality, if I subtract x from both sides, you're going to see right away that, hey, all the x's are going to drop out. X minus x is 0. And we get this statement, 0 equals 1. This is obviously not true. This is a false statement. So anytime you're solving an equation and all the variables drop out, if you get a false statement, that means you have a contradiction, and therefore we have no solution, meaning there is no value that you can substitute into x to make the equation true. On the other hand, you might have something like x equals x. And this one might be kind of obvious because the equation is so simple, but you could plug in any number you want to make this true, right? If x is 2, it's true. If x is 5, it's true. If x is 10, it's true. Any number you plug into x is going to make this true. So this is known as an identity. Okay, every number on the number line is a solution. But it won't always be this obvious. Instead, what you're going to be looking for is, just like with the last problem, if you work it out, just like we work everything else, all the variables here are going to cancel out. But the big difference here is you are going to end up with a statement that's always true. So a statement that's always true, or an equation that's always true, is called an identity. And anytime you get an identity, you're going to say that there are infinitely many solutions. Another way to think about it is that every number is a solution. Okay, so we got contradictions and identities. In both cases, in both of these special cases, what ends up happening when you solve it is all the variables cancel out. And you just have just an equation left over. And that equation is either going to be true, like 0 equals 0, or false, like 0 equals 1. And if it's true, you're going to say there are infinite many solutions. And if it's false, you're going to say there are no solutions. So let me show you a couple of examples here, and then that's going to about wrap it up for today. If we look at this, this first one, we've got a bunch of like terms. No distributive property here, but we do have some like terms. We got 2x plus x. We also have 3 plus 8, so we want to combine those separately as well. So 2x plus x is going to be 3x, and then 3 plus 8 is 11. And you might notice here that we have got the exact same statement on both sides. This is an identity, and if you recognize that, you can basically be done and write infinitely many solutions. Although you might not catch it right away if you're just like, going through the motions and doing all the algebraic steps. You'll catch it on the next step, though, for sure. Because if I subtract 3x from both sides, now there's not going to be any question. All the x's are going to drop out. And now I've got 11 equals 11, which is always true. There's nothing to solve here. Don't say x equals 11, because although that could be true, it could be 12 or 13 as well. Anytime you get an identity like this, you're going to write infinitely many solutions. Okay, that's what you're going to write anytime the variables all cancel out and you end up with a true statement. On the other hand, let's look at this one over to the right that's going to require a little distributive property up front. I'm going to distribute the 3, distribute the 5, all in the same step here. And that's going to give me 3x plus 9 minus 6x equals 5x plus 5 minus 8x. Next, we're going to identify any like terms. And on the left-hand side, we've got some what I'll call linear terms, the ones with the x's. And we also have some linear terms on the right-hand side as well. We're going to combine those too. 3x minus 6x is negative 3x. So we've got negative 3x plus 9. And then over on the right-hand side, we've got 5x minus 8x, which is negative 3x. And then plus 5. And you might see what's going to happen here. And so once you recognize that, once you get to a point where you can recognize that right away, you can kind of stop there. But just like on the last one, I'm going to show you what happens if you keep going. If I add 3x to both sides, all those variables are going to drop out, and I'll be left with this obviously false statement of 9 equals 5. That is not true, never true. Okay, if it's never true, then there are no solutions. This is a contradiction. Okay, these last couple examples might be more like what you might see on the TSI test. First one says find a so that the solutions of ax plus 3 equals 15 if x equals negative 3. This one's just a little tricky in the way that it's worded because they're giving you an x value and actually asking for an a value. So you're not solving for x here. What you're going to do is you're going to replace or substitute that negative 3 into x. So we have a times negative 3 plus 5 equals 15. I'm going to try to advise you to not write it like this, a times negative 3, or even worse, something like this, because this just looks like you're saying a minus 3. Luckily, though, multiplication is what we call commutative, meaning the order doesn't matter. Right? 2 times 3 is the same thing as 3 times 2. So just to make this a little easier to read, I'm going to just reverse the order here and do x times a, where x is negative 3. So I'll have negative 3, which is my x, times a plus 3 equals 15. And now I can solve for a just like I would on any of those other problems. This is one of those two-step equations where first we'll get rid of the either addition or subtraction. In this case, we'll get rid of the addition by subtracting 3 on both sides. That gives me negative 3a equals 12. And if I divide both sides by negative 3, I'm going to get my answer here. I'm going to get a equals negative 4. So this is just a little tricky in the wording there. Just be very careful about what it is you're actually trying to solve for. And our last problem for today says find a so that 2a times x minus 1 equals 6 times x minus 1 is an identity. So for here, recall that an identity is just any statement that's always true, meaning the left-hand side has to be equivalent to the right-hand side. And if we're looking at this equation, we can see that they both have this x minus 1, right? So that part is already kind of set. We already have an identity with those two, but the rest of it says 2a has got to be equal to 6. So if it is an identity, that means the left-hand side needs to be equivalent to the right-hand side. In other words, 2a has got to be 6. And if I divide both sides by 2, you might not even need to do this. if you could just do it in your head, but 6 divided by 2 is 3. So that about wraps it up for today's lesson. In our next lesson, we will go over how to set up word problems, and we'll still be solving linear equations, but the focus is going to be more so on the setup rather than the solving. Here, we've kind of gone through all the steps that you need to know to be able to solve really any linear equation that's thrown your way. So we're going to build on that next time with some word problems. Thanks for watching. Y'all have a great day.